Mm-hmm. Does it have to be? Sino to? Gel TV. Sinong katapos niya? Prince. Um, Hello everyone. So for this video, we'll specifically focus on discussing or learning more about Pokayoke. Okay, first for an overview, this is sometimes many times referred to as mistake or error proofing. Specifically, what we'll learn is that what Yoke is, why it's so important for any continuous improvement practitioner to understand and practice. No, so we'll learn what the different types of Pokayoke devices are, while also seeing some particular examples of mistake proofing devices in action. Okay, for a scenario, what would be a scenario? Um, let's begin first by asking questions such as do you know why most manholes are round? To be sure, there are many different reasons and theories of why manholes are round, but one of the most significant reasons is because a round cover can never fall into one into into the hole, whereas a square or rectangular manhole cover could in fact fall into the hole if inserted the wrong way. And as it turns out, um, this round manhole is an example of what's known as a Pokayoke device. So let's go over the formal definition. It's an error proofing technique. Okay, and Poka actually means error or mistake, and Yoke means to avoid. Now, the true purpose of Pokayoke is to avoid errors or mistakes. And if we believe it or not, we're all surrounded by Pokayoke devices. So, for example, we take this bathroom uh, sink for an example. A potential mistake is that someone may close the drain plug, start running water, and walk away. And then after a few seconds, water could potentially spill out of the sink unless, of course, the sink has a drain hole. And this drain hole is another example, really, of everyday Pokayoke. In fact, anytime a new product or process is being developed, no, thinking of ways to mistake-proof the product or process may be some of the best time spent. So, okay, I think that's all there is for an introduction. So, why Pokayoke? Um, why is Pokayoke so important as part of authentic continuous improvement? To do this, we first begin to explore the relationships between errors and defects. All right. If we think of an iceberg as this one, the part everyone sees at the top, which is analogous to the defect. And as we all know, the largest part of the iceberg is analogous to errors or mistakes. So if you put another way, errors are any deviation from the process, and the defects are produced when products or processes deviate from the specifications or don't meet the expectations of our customers or stakeholders. So in other words, defects are created by errors. Well, to be sure, not all defects really are created equal, and for now, let's explore the different levels of defects. Okay, let's go over. Is it this one? Hold on. Actually, the slide is not here, but probably in the next version of this video, we'll include that piece. But for now, we can discuss the different levels of defects. Okay, first, the most severe situation is when defects are shipped to the customers. And then we have the second level is when defects are found and contained in-house. So in many cases, this occurs during an end-of-line functional test or inspection process. And then we have the third level that occurs when defects are being attacked and reduced. And then we have the fourth level when defects are found, encountered at the source of the problem. So, in other words, guys, once properly countered, this defect should never reoccur for the same root cause. And then lastly, the most favorable situation occurs when defects aren't produced at all. Okay, by finding errors and preventing, which is precisely what Pokayoke is meant to do, then we can prevent defects. In addition to preventing defects, there are other reasons Pokayoke is so important. And probably one of these reasons is due to something called the autopilot effect. So there's this particular book, The Design of Everyday Things. As Donald Normal states, the human brain's default mode of operation is pattern recognition and autopilot execution. So if the pattern is familiar, a behavior that has been successful in the past is launched. It's only when feedback suggests that things are not going as planned, but more in-depth thought is called. So for example, um, have you ever driven to or from work and not remembered it? Or have you ever driven home even if your significant other specifically asked you to stop at this store? Or do your operators sometimes struggle when standard work is updated? All right, let's pause here for a moment. So these are just a few examples of how powerful the autopilot effect can be and why, if not controlled, can lead to problems, including the creation of defects. All right. Now, that said, since most of us work closely with other human beings, it can also be helpful to understand the many different types of error we humans unfortunately make from time to time. Well, of course, just because these errors are induced by humans doesn't mean we ever want to blame people, no? Instead, we must always focus on how we can improve the process, making it difficult, if not impossible, to ever make another mistake again. All right, let's go over to the different types of human errors. Okay, these are the 8 different types of human errors that can lead to defects. One, forgetfulness. Next, misunderstanding, errors, detection errors, and then willful errors, inadvertent errors, errors due to slowness, errors due to lack of standards and supervision. And really, in order to combat these human errors, there are also different levels of mistake proofing that we can employ. Okay, let's go over here. First level, level 0, it focuses on things such as training, standardization, and things such as control plans and SPC. And then we have the level 1, error proofing, where we're able to identify the error with a warning such as an alarm on or on light. And then level 2, error proofing, where we're able to identify the error and the machine or process halts or stops and waits for the corrective action. And then we have level 3, error proofing, where the error is not only identified but is also corrected automatically. And then lastly, we have level 4, and this one makes it impossible for the error to occur. Well, obviously, our goal should be to eventually get to level 4 error proofing, assuming it's feasible and realistic. Well, I mentioned feasible since the cost of error proofing must always be taken into consideration. No, to be sure, the best error proof devices are normally inexpensive and homegrown in nature. All right, and then we go over to the next. We discuss the 3 types of Poka Yoke devices. First, we have um, the warning signal Pokayoke. This may be things such as in lights, as shown here, or even buzzers or other audible signals. So the goal of these devices is simple. Don't pass on bad quality. Secondly, we have shutdown Pokayoke. What does this mean? This may involve a stop the line cord or some sort of auto detect and stop device. All right. Additionally, things like counters that force the process to stop are examples of shutdown error proof devices. The primary function of these devices really is don't accept bad quality. Okay. Then lastly, we have control Pokayoke devices, and this include things such as locator pins, making it impossible to plug something in wrong, or probably stoppers on fixtures, or even indicator lights, helping assemblers pick the correct part. And then we have main goal here is don't make bad quality parts. Now that said, no matter what type of error proofing device is used, there are many different ways of implementing them. Let's go over implementing error proofing devices. The first, manual devices. They're often found to be extremely effective and inexpensive. In other words, we may add a locator pin to a fixture, making it easier to load a part. Then second, we have automation, which we can leverage as well. So for example, we may use photoelectric sensors or more sophisticated vision systems in order to verify parts that have been properly produced. And then we have the third, error proofing. Um, and this can be built into the design of the product or service. So for example, the size of a diesel fuel nozzle is typically a different size than a gasoline nozzle, apparently, making it difficult for someone to mistakenly put diesel fuel into their gasoline powered vehicle. Now, in terms of implementing Pokayoke, so far, we've learned what Pokayoke is, why it's important, and the different types of devices that we can use. Now, Let's switch gears for a bit and talk about how to go about implementing Pokayoke. So first of all, once an error is detected, we should immediately contain the problem in order to first and foremost protect our customer. And this may require a so-called band-aid solution, meaning it's a temporary solution put in place. Now, once the problem has been contained, we should immediately enter into problem solving mode, no, in order to identify countermeasures that result in the creation of a Pokayoke device or even multiple devices, no. And third, we should continuously strive for zero defects. So for example, or perhaps we have a warning and on light installed to alert us when a defect is produced. So which then helps prevent defects from being passed on. And then perhaps we can find an even better device that makes it impossible to produce a defect. So here's a set of questions that can guide us. It can be used to ensure our or your Pokayoke device will be safe and effective. Is first, does it prevent the reoccurrence of the error? Then second, does it use bits over wallet? So in other words, the best error proofing devices, guys, are usually inexpensive and creative. No, you don't need to spend a lot of money to mistake proof a process. We also want to ensure the device is easy to use. It's safe, simple to implement, and finally, we should be able to easily maintain the device and it should be durable. No, that said, the ultimate test of any Poka Yoga device is to intentionally try to make it fail. So you see, beings are very ingenuous and may eventually find situations where the Pokayoke will fail to prevent an error. So for example, with a little work, even a square peg can fit into a round hole. See if it's possible to make your Pokayoke device fail under normal or simulated working conditions. All right, I think we have to check our time for a bit. All right, I believe we've exceeded the allowable time. For now, let's stop for this video. And there you go, darling friends. If you enjoyed this video and you'd like to see similar videos in the future, don't forget, of course, to like, comment, subscribe to my YouTube channel down below, and hit the notification bell as well so you get notified of important learning updates, of course. Thank you for today and have a great day. Bye.